Alright guys, welcome to another math tutorial video. The subject of this one being simplifying radicals. Now this term radicals can often be a little foreign to some people if they haven't heard it before. But what radicals means essentially is square roots. You all know that, right? The square root sign, just like that. Simplifying radicals is another way of saying to simplify a square root. We say radical because it's a little bit more of a broad term, because even though we're just going to be talking about square roots today, this does cover the topic of cube roots or fourth roots or all of the above, right? So this is a pretty broad topic, but we are just going to be talking about square roots in this video. So let's go ahead and give an example. What's a good number? Let's say the square root of 80. I like that. Square root of 80. Now, how do we simplify it? Now, essentially, the square root of 80, there's nothing wrong with writing it like that, or there's nothing wrong with simplifying it into a whole number, but mathematically, there can be some easier ways to write it and some ways to write it that are going to be a little bit more beneficial for our solving of problems. So what we're going to do here is the first thing, we essentially just want to make a factor tree of 80. Now I know you probably haven't made a factor tree since you were in like 4th grade, but that's actually just what we got to do here. So we're going to break it up. Let's see, I'll break it up into 8 and 10. Then break it up into 5 and 2. What I've noticed a lot of my students like to do is just break the number in half each time. So they would be like 80, well 2 and 40, and then 20 and 2, and 10 and 2, that kind of thing, which works perfectly well. Let's see, 8 breaks up into 4 and 2, and then 4 will break up into 2 and 2. So now what we want to look at is strictly our simplest numbers here. So these 4 2's and this 1 5. Those are the only numbers we want to look at. We don't care about this 4, we don't care about this 8, and we don't care about this 10 anymore. Now we need to group our numbers into pairs. Luckily, we have a pair of 2's right here, so I'm going to circle that. Then we have a pair of 2's right over here, excluding that 5. Now we only have 1 5, and that's okay. We don't have to have a pair for every number, but the numbers we have pairs for work a little differently than the ones we don't. What I always like to say is that the first step after you've made your factor tree is just to draw a square root sign, just like that. Now on the outside of the square root sign, right out here, what we're going to be writing is the numbers we have in pairs. Now for each pair, we will only write one number. This is the key. Since you have a pair of 2's, you don't write 2 times 2, you just write a 2 out there. Now in this case, we do have 2 pairs of 2's. So for this second pair of 2's, we write one more 2. Now what these numbers are going to do is multiply. Just like whenever we're going to write multiple numbers underneath our square root in this case, we would multiply those as well. So underneath our square root, we put all the numbers that are just by themselves. Now for every number we have by itself, we just drag it under there. Now we only have 1 5 kind of on its own here. That's the only one. So that 5 is just going to be written right under this square root. And we're not going to have to do much else with it. Now at this point, we can multiply those 2 2's. 2 times 2 is 4. We have that square root of 5 next to it, and this is our correct answer. If you really wanted to try it, you can put it into your calculator. You can write 4 square root of 5. These are multiplying, we just don't have that multiplication sign. And you'll get the exact same number you would if you wrote in square root of 80. So let's do another example of this. Let's say the square root of 96. Now, whenever I look at the square root of 96, I'll break it up into 4 and 24. Now 4 will break up into 2 and 2, and 24, what should I break it up into? Let's do 4 and 6. 2 and 2 for that 4, and then 3 and 2 for that 6. Now we don't care about any numbers that are not in their simplest form, so we just have these 2's and that 3. Now we have a pair of 2's here, we have a pair of 2's here, but then we have this 2 all by itself, and we have that 3 all by itself, right? So our first step, going to be drawing that square root. We'll put one number on the outside for each pair we have. So 1 2 for the first pair, and a second 2 for our second pair. Underneath, we're going to put each number that doesn't have a pair. So a 3, and then we multiply. Every time we put multiple numbers under here, we multiply them. And then a 2, because those are all by themselves right here, right? So 2 times 2 is 4, 3 times 2 is 6. So it's not that different from our previous problem here, right? We got 4 square root of 5. Here we just got 4 times the square root of 6 for the square root of 96. Now let's try one more example up here. Let's try the square root of 128. Why not? That sounds fun. Okay, now I'm going to use the process my students like to use. 2, and what would this be? Oh goodness, 64. 2 times 64, right? 64 can break up into 8 and 8. 2 and 4. That 4 will break up into 2 and 2. 2 and 4. 2 and 2. All right. Pair of 2s. Pair of 2s. Pair of 2s. And then a 2 by itself. So let's simplify. We'll put a square root in. 1 2. 2 2s, 3 2s, and then 1 2 that's all by itself that will go under the square root. 2 times 2 times 2 will give us 8 to the square root of 2. That's our final simplified answer for the square root of 128. Now, you may notice that generally we're going to get 2s in pairs, right? That's the most basic number for stuff to simplify down into. But occasionally you will get 3s or maybe even 5s, you know. But generally it is going to be 2s. Now, so yeah, that would be the square root of 128. Now, the last thing I want to do here is just one quick example showing that this works even for numbers like this, square root of 36. Now, we all know the square root of 36 is just equivalent to 6, right? 6 times 6 is 36. But this method will still work. So if we break down 36, we would say 6 and 6. 6 would break up into 2 and 3. 2 and 3. So we could group these 3s together, and then we could group those 2s together, right? So that would mean under our square root, we would have nothing. We would just have like a 0 under there, and we would have a 2 out here for our first pair, and then a 3 for our second pair. Now, of course, the square root of 0 is just nothing. It doesn't exist, right? So we don't even have to worry about that. And we just get 2 times 3, or 6. So this method will still work on numbers that have perfect squares. You just won't get any numbers to put under that square root. So don't be alarmed if you get all of your numbers being pairs. It just means that number is a perfect square. So if you have any questions, comments, or concerns about this, feel free to leave them below or at my blog, mrmathclass.blogspot.com, and I'll be more than happy to answer them. Thanks a lot for watching, guys, and I will see you next time.